Example 11. A product code consists of a string of 4 different letters. Let's note that those are different letters. So if we were to make a set of event blanks, we'd have to go 6, 5, 4, 3, 6 because there are 6 elements in the set. It says how many such codes contain the letter H and Q or both. And to be clear here, I think this should actually just be a comma. It should not have the word and. So this is a fairly complicated restriction because we have to think of the codes that have only an H, only a Q, and then perhaps one of each. And then you got to think, okay, well, is the code HQ blank blank? Is it blank HQ QH? There's all these different permutations of where these could rest. So I'm going to show you an easier way to do this problem by first taking the total amount of codes and taking out what we don't want, which is any code basically with no H and no Q. So let me read the problem again. It said a product code consists of a string of 4 different letters. How many such codes contain these letters? So we want to know how many do have H's and Q's. So if I take the total and I take out what I don't want as my answer, I'm left over with the only remaining, which is everything that does have an H, a Q, or both. So those totals would be minus 1, 2, 3, 4. I am going to use a product code to figure this out. So if we start with anything that's a total, we start with the total in the elements, which was 6, 5, 4, 3, and that again is because they have to be different. Otherwise, we could just say 6, 6, 6, 6. And now if we're talking about any code that has no H or no Q, just eliminate those from your set, and this becomes 4, 3, 2, 1. And that just breaks down to 360 minus 24, and our answer is 336. I have a much longer way to show that. If you'd like, you can message me separately. Example 12. Set S 1, 2, 4, 5, 6, 7, 9, and suppose a 4-digit number is formed by selecting digits without replacement from S. How many different such numbers can be formed? Well, first we need to know how many numbers we're dealing with. So let's go back. 1, 2, 3, 4, 5, 6. There are 7 numbers here. So if we were to come up with a 4-digit number, that would be 1, 2, 3, 4, 7 without replacement. So I'm not putting it back. I can't use it again. That would be a permutation. So there are 840 total codes. How many different such numbers can be formed if both even and odd digits must be used? So you must have a mix here of even and odd is what they're saying. So again, you have to think, well, where's the even going to go? Where's the odd going to go? Is it 3 of one, 1 of another? Is it 2 and 2? This, like number 11, is also very tricky. So I'm going to go back to my earlier strategy of finding the total. And I'm going to take out 2 groups of codes. Those 2 groups are where we have all even or all odd. And if you say or, I know we usually think of that as addition. In this sense, you would think of it as subtraction because you're taking away. But addition and subtraction are often looked at as opposites or paired together. So total-wise, I've already found my total. I don't need to find that again. And then I'll use event blanks to figure out how many such codes are all even and all odd. Okay, so if I select codes that are all even, it means I can't use any of my odd numbers. And you'll see there's only 3 left. So I actually cannot produce codes that are all even. Can't do it. If I go back and I look at this in terms of all odd, that means I cannot use any of the even numbers. Which leaves me 1, 2, 3, 4 choices, 3, 2, then 1. So 840 minus 24. There's 816 different codes that have to use one of each. Example 13. Saturday Night Live is working on their show. They currently have 6 skits and 10 commercials to show. The order must go commercial, skit, skit, commercial, skit, skit, commercial. Each skit will only be shown once, but commercials may be shown multiple times. How many possible television shows can be aired? Alright, well, let's see. So it said first that there were 6 skits and 10 commercials. 6 skits, 10 com. And those are actually the outcomes. The events that are going to take place are right here. That's where it goes commercial, skit, skit, commercial, skit, skit, commercial. Okay, so commercial, skit, skit, commercial, skit, skit, commercial. And it says the skits will only be played once. So I have 6 choices for my first skit, but then after that they start to dwindle. And you'll notice that I have a commercial in between here. Well, when we come back from commercial, I've already used 2 of my skits. So what I need to think about here is continuing my step-down multiplication or my permutation in only the S blanks. Okay, so this is like 6 permutation of 4. And then if I wanted to, I could rearrange these numbers, but I'm not going to. I don't need to. I'm just going to skip over those. And that keeps my order in place. When I go to the commercials, it says there are 10 commercials to choose from, and it does not matter. I could use the same commercial over and over and over. And bottom line, this is just a counting technique that helps us multiply all this together. So altogether, 360,000 different shows. Example 14. The basketball coach has 14 players. He needs 5 players to start. Okay, he needs a point guard, a shooting guard, a small forward, a power forward, and a center. 6 players can play any guard position, and the others can play any forward or center position. Okay, well it said there were 14 players, so that leaves 8 others that can be either forward or center. How many starting lineups are possible? I think this goes without saying that you can't play 2 positions in basketball, otherwise there would be 4 people on the court. So when I decide, let's say, how many people I want to use as a point guard, so this should be point guard PG, shooting guard PG, I can use 6 for my first choice, but I can only use 5 for my second choice. And then so that takes care of all the shooting guard. There's 30 different combinations of how those 6 players can fill those 2 slots. And then I move on to the 8, step down to 7, then 6, for a total of 10,080 different lineups. Remember that when you do fantasy next season. This last section here will go much quicker because it's pretty easy, but what it's designed to do, let me give you the formula first. Let's say you have some number of elements. They can be letters, numbers, whatever. It could be seats at a table, and you're trying to determine how many ways you can mix it up. Okay, much like the questions we've been asked. If you then think about some ways of, let's say, a word being similar to another word because they have repeated letters. Like if you look at example 15, it says how many different 6-letter words can be formed by the letters in the word keeper. Well, if you notice, if I mix around these 3 letters, these 3 E's, technically I could get 6 more combinations of the same exact word. I could say, well, this E goes here and this E goes, that's nonsense. So we're not going to count the ones where there are repeats in the same position. So all we do is we figure out how many things are being repeated. We call that R. And doesn't matter how many there are. There could be 1, there could be 2 repeats. We could just call this repeat number 2. We just divide those out as a factorial as well, because I'm mixing up 3 e's. The reason I said there's 6 different words for keeper is because if I mix up 3 e's, that's 3 times 2 times 1. Okay, so since there's 6 letters total on this one, the answer is 6 factorial over, divide out the repeats, and your answer is, let's expand this to kind of get a better feel of what is happening when you put this in your calculator. Oops, that's a 2. These cancel, these cancel, these cancel, and you're left with 6 times 5 times 4, or 120. Let's try another one. How many different 7-letter words can be formed by the letters in the word letters? Okay, thing to note here is that there are 2 T's, 2 E's. So there's more than one letter being repeated. And that's why I said R could be R1, R2, R3. The point here is that you're mixing 7 letters, and you want to divide out the 2 T's and the 2 E's. And you can just put this in your calculator, simple division problem, you get 1260. If you have any questions on calculator, phone, or normal, just shoot me a message. And the last one, number 17, how many different 11-letter words can be formed by the words in Mississippi? See if you can do this one on your own. All right, check your answer with mine. First, there are 11 letters. That's your numerator. There are 4 I's, 4 S's, and 2 P's. So you will divide out 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. And your calculator should give you 34,650.